Hello everyone. This lesson is going to be about the variance of continuous probability distributions, as the title says. Now here's our formula. You will recall when we studied discrete probability distributions in the past that the variance of a discrete distribution was the sum of the probability function by x minus the mean squared. So there's an obvious similarity between these two rules. When we are using discrete variables, we sum the individual values. When we're using a continuous variable, we have to use an integration between the lower and upper limit for the interval that the probability distribution is defined on. But the rest of it, the bit in the middle here, looks the same. So that's nice that it's consistent and it's easier to remember. Now this equation, both of those equations are on your formula sheet, but the topic for today is continuous. So let's first start, as we did last time, with a uniform distribution. Now, let's just make this up as we go along. This will be the value of the probability density function. This will be the value of the continuous variable x. Let's say that the lower limit a equals 5 and the upper limit b equals 25. Now, as a uniform distribution, then all the probabilities are equal, so we have a nice little rectangular line there. Just tidy that little corner up a bit. And of course, one of the most important things that we need to figure out is the height of this distribution, the value of the probability function. Remember, the fundamental idea, as always, is that the area, the total area under that block must equal 1. Now, the difference between b and a is 20, so we must have a height here of 1 over 20. This defines our probability function, px, is the constant number, 1 over 20 in this case. Now let's find the variance. Before we can find the variance, we need to know the mean. And we saw last time that for a uniform distribution, the mean value is exactly halfway between a and b. Now this is only for a uniform distribution, of course. Halfway between these is a value of 15. Don't make the mistake of using that idea on every distribution that you ever find. That would be a big mistake. If you needed to find the mean for a distribution that wasn't uniform, you would of course use your formula that we learned last time, the integral from a to b of x by px dx. Now if you were to do this, you would of course with this distribution still find that the result comes to 15. So let's move on to this idea of variance, which is the main idea for today. The variance of our probability distribution, which can also be symbolized as the standard deviation squared, is equal to the integral from a to b. Let's go and check our formula. It's the probability function px by x minus mu squared dx. There we are. Now, what's our function look like? Our lower limit was 5 and the upper limit is 25. Our probability function has the value 1 over 20. X is a pronumeral. The mean is 15. All this is squared, and then we use dx. Now this is a definite integral, which we need to evaluate. Depending on the exam you're in, if you were in a tech active exam, then at this stage I would be saving myself the time and effort of expanding and integrating, and I would be using my technology to its full advantage. So let's write this as x minus 15 squared over 20, integrating between the limits of 5 and 25. So I get 100 over 3 or 33 1/3. Remember, tech active exam, use the technology as much as possible. And sometimes, remember, that's the variance, or sigma squared. Sometimes, of course, they want the standard deviation, which in this case would be the square root of 100 over 3, 10 over root 3. We wouldn't leave it like this. We would rationalise the denominator, and we would express this as 10 root 3 over 3. And once again, if they actually want a value for this, your calculator is your best friend. So let's take the square root of the previous answer, and then 5.77. That's going to be approximate enough, 5.77. So that's how we do the variance of a uniform distribution. Now, of course, the same rule applies to any distribution, but this example was a uniform distribution. Okay, thanks for watching.